हेलो 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 एंड वेलकम बैक एवरीवन टू डिस्कवरिंग कोड। आज हम फिर से कंटिन्यू करने वाले हैं 900 सीरीज का क्वेश्चंस एंड टुडे वी हैव अ वेरी गुड named question called bad boy. So let's get into it, but let me just start the timer first. Here we go. Let's get into it. So Riley is a very bad boy, but at the same time he's a yo-yo master. So he decided to use his yo-yo skills to annoy his friend Anton. Anton's room can be represented as a grid with N rows and M columns. Let's create a grid. Let me turn this white and uh, let's create a 3 by 3 grid for now. Mm, there we go. There we go. There we go. Beautiful. All right. So here our N is 3 and our M is also 3. All right. What is next? Let IJ denote the cell in row I and column J. Anton is currently standing at position IJ in his room. To annoy Anton, Riley decided to throw exactly two yo-yos in cell of the room. In the cells of the room. Okay. They can be in the same cell. Okay. Because Anton doesn't like yo-yos thrown on the floor, he has to pick both of them and return back to the initial position. The distance traveled by Anton is the shortest path that goes through the positions of both yo-yos and returns back to IJ by traveling only to adjacent by side cells. Okay, what does that mean? By traveling only to adjacent by side cells. That is, if he is in cell XY, so let's assume he is in this cell, Anton. So he can travel to x plus 1. Uh, x plus 1 would be this actually. X plus 1, x minus 1, y plus 1, y minus 1. So up, down, left, right, in one step. Riley is wondering where he should throw these two yo-yos so that the distance traveled by Anton is maximized. But because he is very busy, he asked you to tell him. Okay. Uh-huh. So, all right, let's go through. Yeah, let's say Anton is standing here. Now we have one yo-yo at the end, obviously, so that he has to go through this. And then we can also place it, we can place it here, and place it at the center. Okay, we'll count. Let's say 1, 2, 3, right? Now, if we place, he has to go this, this, or like how many is that? 1, 2, 3, and 4. That's 4. And if he goes like this, 2, 3, and 4. So equidistance, because we took n equals to 3 and m equals to 3. So that's equidistant. So it doesn't matter where we place the second one. As long as we place this one here, it's gonna take this long of a length to reach, and it doesn't matter, he can pick it up either way. If you place it here, here, or here, or here, it's gonna take the same amount of steps to go back to the initial position. uh, is that true for every single grid that we have? So this example that we are given, in which we have something like this, sorry for the bad writing, Anton sits here, the this one is here, the first one, and the second one is here. So if he goes this way, like that, even that is equidistance. Let's take another grid. Let's make it a little bit bigger. uh, let's do something like that. So Anton sits here, If you place it here, I think that is still the max distance, right? Uh, and then if we place one here, like, okay, we'll count. The one way is this, another way is this, and then the last way is this. So let's calculate one, two, three, four, and five. So this one, this one took five, right? If we go through here, then one, two, three, four, five. This also took five. And if we go through here, then one, two, three, four, five. I mean, it takes the same steps, the same amount of steps. For n equals 4, sorry, n equals 3 and m equals 4, it still takes the same amount. So, uh, I mean, isn't it that we can just put the last one at the last cell that we have? So x is equals to maximized whatever maximum cell that we have, and y is also the max uh, that we have, max I and max j. And after that, it's just gonna take the same amount of steps to go back to 0, 0 as it did coming here. So, and we can place the second yo-yo anywhere. He'll just pick it up on the way, right? Or, wait a minute. If you place it here, then you can just go like that. It still takes 5. Place it here. He goes like that, that, yeah, yeah, it doesn't matter. You can just traverse. These three are covered. We just covered this, this, and we covered this as well. So yeah, I think it takes an equal amount of time or equal amount of steps if we place the first yo-yo at the edge of the other side of of the matrix, of the room, and on the way he can just pick up the second one. So okay. Mm, so what do we have to uh, what do we have to output? So the input is like, okay, we have this. The only line of each test case contains 4 integers, n, m, I, and j. Okay. Oh wait. So the initial position is not always 0, 0. Is that also true? Uh, Anton is currently standing. Oh, okay. Okay, okay, okay. That kind of changes things. I was always, uh, I always thought that it might be always at the first cell, but that was my bad. I had to read it properly. So it seems that okay, the Anton's position could be anywhere in the cell. Okay. This is maximized. Okay. Why is the output like this? Print 4, xy, x1, y1, x2, y2. Corners of the two U should be thrown. Oh, okay. If multiple answers are present, you print any. Okay. So the problem now is we are given a position in the grid, I and j, and we need to figure out how far left or right to the boundary we are. Like we need to figure out in the grid where we are so that we can figure out which is the furthest away cell from that position, right? I think that is the problem now. Uh, and with ij given, I think we can easily. Okay. Uh, the first one should be the furthest away. The second one we can place it in the same cell. It doesn't really matter where we place the second one. As I said, if we go furthest away from Anton and place one yo-yo there. The other one, it does not really matter where we place the other one. Wait, let me visualize this. I could be wrong. Uh, Let me draw another one of these. Beautiful. Oh my God, my hand. There you go. There you go. There you go. Look at that. Oh my God. Okay. All right. Let's say Anton starts here. All right. So this is what? 0, 1, 2, 3, 0, 1, 2. All right. So Anton starts at 1, comma 1. Okay. Now, where shall we place the yo-yo? So as you can see, the furthest away cell is still the bottom right cell. And if we place it there, then he has to go here, 1, 2, 3, and then so it takes 3 steps to come here. And if we place the other one here, then it goes 1, 2, 3, 4, 5. And then he has to come back 6 and 7. Okay, this problem is now getting a bit out of hand. The only okay, just 1 second, and the uh, tick, 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 tick. Okay, so basically, if Anton is at the starting cell, we place both of them here because that's the most opposite cell to it. And if he's not at the starting cell, then easily we can place it directly opposite diagonals. Like that's the only solution I can think of, because he has to travel again and then go back to wherever. If he's here, 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 then it's easy. We place it here and we place it here. The most bottom right and the top left side. And then he has to traverse the whole grid to get there if he's not at the starting position. If he is at the starting position, it doesn't really matter because he has to travel the whole grid anyway, and he will pick it up as we uh, saw in the previous example in this grid that I showed. So I think that's the only logical solution I can think of. Like, yeah, you can see, right? All of these, I can see 1, 1, 1, 1, 1, 1, right? And for the first one, it's what? Okay, let's actually visualize all these. So first we have it's what? X1, Y1, X2, Y. No, sorry. N, M. N is I should decrease the stroke width here. Can't I hide this? Uh, okay. So N is what? 2, M is what? 3, and then the starting position is 1, 1. So N is 2, so 1 line, and then 3 for 2 lines, and starting position is here. And then okay, yeah, we can just place the ball here, which is what? 1, 2, 3, 1, 2, which is what? 3, comma 3. So wait, x1, y1, x2, y2. Mm, 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 mm. Oh, oh my, oh my, oh my, oh my, oh my. Okay. So first one we place at the end, which is 2 comma 3, and then on the next one we can I mean we can just place it at 2 comma 3 as well, because it says multiple answers you may print any, and we can place both of the balls in the same cell. So we'll just place it like that, and this will also give us the correct answer. And if Riley was supposedly here, we'll place it here and here. So he has to go here and then here and then here and then here and then go back here. So that will give us the maximum. So yeah, yeah. I think that's the length of it. Let us try and code this. So let's take the input. Uh, and is it? Oh, sorry. 10 to the power 9, right? I think we can take um for next equals to next and I is and j equals to next. Awesome. Now, what did we say? Uh, the starting position. We need to figure out if I is equals to 1 and then j is equals to 1. Uh, I mean, there's a sanctity check that we could do, that if I is greater than n and j is greater than m, then don't do anything. But yeah, as they mention it here, it's already in within range, so no need for that. And if this is the case, we could go ahead and just directly print uh, out dot println uh, n plus space plus m plus space plus m plus space plus right. uh, if if Anton is standing at the initial position, we can directly print the edge of the room as our solution for both the yo-yos. And if not, then the opposite sides. So it's uh, mm, out of println uh, it goes like okay. The first cell and the last cell. Um, I mean, this just looks. Oh, I don't even know if this works. But I mean, what directly in outputting the answer, but let's see. Uh, oh, there should be a space here. There we go. Let us, I mean, I don't know if there's a point. I mean, there is a point. We need to check if there are no runtime errors or something, compile time errors. But yeah, okay. So, uh, Not so sure about that. Not at all sure about that. Definitely not sure about that. I mean, let's go ahead and submit this. I don't know. Let's see. That boy is actually pretty bad. Let's get this out of the way. Let's make it main. Let's save it. If you've been following, I don't save, but I should. Should always save. Let's see. Mm, da, 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 da. Holy cow. Let's go, guys. It is accepted, and my intuition was correct. So, yeah, very nice. Let's go ahead and solve this, and we're done. Let's see what the notes say. Uh, yeah, there we are. Exactly. Yes, I did it. So that's it, guys. 21 minutes. That's quite a lot, but I had to visualize everything just to get the correct answer in mind. So, yeah, that's all. I'll see you in the next one. Until then, I hope that you keep doing well, and whatever you're doing at life, just keep at it, just keep walking, and it will come to fruition. With that, I will leave you guys. Have a good night, good day, or good afternoon. Bye bye.